Hello and welcome students. This is lecture number 7 in mathematical logic. In last lecture, that is in lecture number 6, we have studied the following things. That is, we studied what is a statement pattern. Then we studied how to construct truth table of a statement pattern. The next we studied was when do we call a statement pattern to be a tautology or a contradiction or a contingency. We saw this. Finally, we solved problems on the above concepts. Today in lecture number 7, we are going to deal with a very important concept of logical equivalence. We are going to study about logical equivalence logical equivalence of statement patterns. So let me first teach you what is meaning of logical equivalence of statement patterns. So suppose you have two statement patterns. Suppose you have two statement patterns. The first one I call it as S1, and say S1 is negation of P and Q. The another statement pattern is S2, and it is negation of P or negation of Q. These are two statement patterns you have. Now what you notice that in these two, the component statements are P and Q. In above statement patterns, the component statements are P and Q. Now you know students that P and Q, which are two component statements in both the statement patterns, they will have each one of them will have two types of truth values. That is, this one will be either true or false. This one Q also will be either true or false. Now what happens is, when you decide the truth value of these two component statements, when you decide the truth values of these two component statements, for those given truth values, you will find the truth value of statement pattern S1 and the truth value of statement pattern S2. So suppose you decide P Q, you decide P to be true and Q to be true. So for P true and Q true, you find the truth value of S1. You find the truth value of S1, and here you get something. Then you find the truth value of S2. You get something. You will notice that what you are getting for S1, the same truth value you are getting for S2. Then you decide P to be true and Q to be false. The next combination of truth values of P and Q. You find the, for P true and Q false, you find the truth value of S1. You get something. Suppose you get something here. You notice that the truth value of S2 is also same. You are getting same truth value. I'm not writing the truth value, I'm just writing the symbols to make you understand. So you notice that you are getting same truth value for both. Then the next combination is, here you have P is false and Q is true. So for P false and Q true, you find the truth value of S1. Suppose you get here something, and when you find the truth value of S2 for P false and Q true, once again you get the same truth value. Then final combination you have is P false and Q also false. You find the truth value of S1. You find the truth value of S1. You notice what truth value of S1 you got, same truth value you get for S2. So once again you are getting the same truth values. So what you notice? You notice here that you notice that S1 and S2, you notice that S1 and S2, they have identical truth values. S1 and S2, they have identical truth values for the given truth values of their component statements. They have identical truth values for given given truth values of their component statements. Now since I have the identical truth value for S1 and S2, you can see the column. You can see the column. Since you have identical truth values, you will say that statement pattern S1 and S2 are logically equivalent. What you will say? You will say S1 and S2 are logically, they are logically equivalent, and this concept is known as logical equivalence of statement patterns. This concept is known as logical equivalence of statement pattern. Now what I will do is I will find out the actual truth value for S1 and S2. I'm going to construct the truth table of these two statement patterns in order to make you understand properly what is logical equivalence of two statement patterns. Before I had given you the rough idea of equivalence, logical equivalence of two statement patterns. Now I'm going to construct the actual truth table. So this is your truth table, P and Q. Now I will construct. So here I have got, see, I have to construct the truth table of both the statement patterns simultaneously. So see, I will take care that I have enough columns in order to have both of these in one table. So here I have negation P and negation Q. If you remember, while constructing the truth table, after P and Q, the next we go for negation. So here I will go for next column as negation P. Then after that I will go for negation Q. Then I will go for P and Q. After P and Q, I will go for negation of P and Q. And finally, I will go for negation of P or negation of Q. So let's do this. Negation P, you know, if P is true, negation P is false. So here you have false, this is false, true and true. Then negation Q. Q is true, so here false. Q is false, so here I'll get true. This is false, and here I will get true. Now I have to go for P and Q. What is the law for P and Q? P and Q is true when both P and Q are true. In all other cases, it is false. So see, P true, Q true, then true. And all other cases, it is false. No need to worry much. Just write, follow the law. Then negation of P and Q. Negation of P and Q is negation of P and Q. So P and Q is true, so this is false. And elsewhere it is all true. Here you have in the final column, you have negation P or negation Q. That is, you have to get the negation, you have to get the disjunction of these two columns, negation P or negation Q. Now, what is the law for disjunction? The law for disjunction is when these two are false, then false, otherwise true. So both are false, so false. Here true, here true, and here also true. Now you can notice, let me now number the columns. So this is column number 1, column number 2, this is 3, this is 4, 5, 6 and 7. Now students, if you check the column number 6 and 7, check the column number 6 and 7, what you notice? You notice that these two columns are identical. These two columns are identical: false, false, true, 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 true. So what I can say? I can say that this statement pattern, which I called it as S1, and this statement pattern, which we called as S2, these two statement patterns have identical truth values for the given truth value of their component statements. Hence, S1 and S2 are logically equivalent. From column number 6 and 7, you check that the truth values of both the statement patterns are identical. So you will say that statement pattern S1 and S2 are identical. Hence, you can write, finally, you can write negation. I write it here. I can write finally negation of P and Q is logically equivalent. See, this is the sign for logical equivalence. You draw three parallel lines, is logically equivalent to negation P or negation Q. Let us now define logical equivalence. Two or more statement patterns, two or more statement patterns are said to be logically equivalent, are said to be logically equivalent if and only if and only if they have identical truth values, identical truth values for the given truth value of their component statements. What is this, students? It is the definition of logical equivalence. This is definition of logical equivalence. You can copy the definition and also the explanation. Question number 7, the book which I am following, in that question number 7 says, prove that the following pairs of statement patterns are equivalent. So from there are several questions. So I select question number 2. To prove that, P double implication Q and P implies Q and Q implies P are logically are logically equivalent. So here students, we have two statement patterns. One is P double implication Q and the other is P implies Q conjunction with Q implies P. What we have to do here, we have to prove that these two statement patterns are logically equivalent. So for that, what I will do, I will first construct the truth table. Now you all know in truth table, we will have first row as the header. This is the header. And then after that, I will have 4 rows because I have PQ, 2 component statements. So here I will have 4 rows below this. First column is always P. The first columns, the first 2 or 3 columns are always for the component statement. So here, since we have 2 component statement, I will have only P and I have 2 columns, that is P and Q. So P here, Q here. This row is header. I'm going to have header here. Now I'll write the truth values of all possible truth values of P and Q. So you know that T, T, F, F. Here I have T, F, T, F. After this, I shall go for negation. I will check, do I have negation anywhere? No, I do not have negation anywhere. So I will go for, then I can go for either of these two. See, I can go for P double implication Q, or I can go for this or this. That is okay. So we can go for either of them. So what I will do is, let me go for double implication first. I will go from left to right, so P double implication Q is what I go for in the next column. So P double implication Q will come here. Then I will go for P implies Q. P implies Q in the next column. And after that, I will go for Q implies P, Q implies P, which is the next bracket. So this is done. This is also done. After that, finally, I will go for P implies Q and Q implies P. So we have we have completed all the required columns. Let's now fill this. Let's do the correct entries here. So see, P double implication Q, I have to write the truth values here. You know the law for double implication. The double implication law is when the component statements have same truth value, then the double implication is true. So true, 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 false, false, true. Elsewhere it is false. Then we have P implies Q. In P implies Q, what is the law? The law for P implies Q is if you have, the law is if you have true implying false, then it is false. Otherwise, it is always true. Okay. So what we will have true implies false, I will have to check whether I have true implies false. So see, true implies false is here, you know, so this will be false, all else will be true. You got that? Next, Q implies P. Once again, Q implies P. So this time you will have to be careful, cautious. Why? Because now you have to see from here to here. Q implies P. So you have to see in backward direction. So students, once again, but the law is same. What? If you have true implying false, then false. So see, true implying true, false implying true, true implying false. See, true implying false. So here you will get false and rest all will be true. If you know the law, then making the correct entries for the truth table become very simple. That's why I have always told you, learn the laws of the compound statements, truth values of compound statement. Finally, I have, okay, let me write the column number. So here I have 1, 2, 3, 4, 5, and 6. The sixth one is conjunction of P implies Q and Q implies P. That is the conjunction of fourth column and fifth column. Now you know the law of conjunction. If you have conjunction, then if both are true, then true, otherwise false. So see here, both are true. So here true, false, false, and true. Okay, because again both are true here. Now check this and you will know whether the given two statement patterns are logically equivalent. So where is this? It is in column number 3. And where is this? This is column number 6. Look at column number 3 and column number 6. Let me highlight it. Let me highlight these two. So column number 6 and column number 3, you will find that all the entries that you have made in these two columns, they are identical. True, true, false, 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 and true, true. So here what the final answer you will write? You will write from column number 3 and 6, from column number 3 and 6, we notice that all the entries are identical. All the entries are identical. Therefore, the given statement patterns are logically, excuse me, are logically equivalent. They are logically equivalent. This is how you have to solve. I hope you all have understood this. Let's solve one more question. Now in this question, we have got 3 statement patterns and we have to prove that these 3 statement patterns are logically equivalent. We have 3 statement patterns this time. You know the method. We will construct the truth table. In a single truth table, we will have the truth values of these 3 statement patterns, and we will see whether they have the identical truth values for the given truth value of their component statements. Once again, students, I noticed that in these 3 statement patterns, we have 2 component statements, that is P and Q. So I will construct the truth table here. So the first one is header. After that, I will have 4 rows. The first column is P, The second column is Q. Then check, do you have negation P? Yes. The third column is negation P. Do you have negation Q? Yes, you have negation Q also. You can see here. So the fourth column is negation Q. After P and Q, always go for their negations. Okay. Then after that, see, then you are free to go the way you want. So I will go for P implies Q. So I will get here 1 P implies Q. Then I will go for negation Q implies negation P. And finally I will go for negation P or Q. Negation P or Q. So now let me write the header. So this is P. I will use some other color. This is P, this is Q, negation P, negation Q. Then I have P implies Q. Then I have negation of Q implies negation P and negation P or Q. So this is all done. I don't need this part. So now I will make the entries for the truth values. As you know, T, T, F, F. Here you have TF, TF. Negation P. Negation P will be F, F, T, T. Then negation Q. It will be F, T, F, T. While constructing the truth table, you need to be very careful. Please do not overwrite, because if you overwrite, then the truth table looks very untidy. Very untidy. Do not overwrite. Say by mistake, if you have where you had to write false, you have written true. For example, I wanted to write false, but I wrote true. So please don't make this as false like this. Don't make it false like this. No, please. Some students try to make it false like this. No, please don't do this. The best way to rectify is, if you have written true for false, the best way to rectify is you put a cross. A single cross is enough and write false. A single cross is enough. Once again, don't do this. Don't do this, please. It will make the table very untidy. So here we have made the entries for the 4 columns. Let me write the column number 1, 2, 3, 4, 5, 6, and 7. Now I go for the 5th column. P implies Q. You know the law of implication. If I have true implying false, then false, otherwise true. So here true implying false is here. So this is false. Rest all are true. Then the 6th column, I have negation Q implying negation P. Negation Q implies negation P. So here you have negation Q. Negation Q is here and this is negation P. So you are going in this direction. Please be sure. Be careful because you are going in backward direction. So check where is true implying false. True, false, no. Here it is. See, true implying false. So here you will write false and rest all are true. Rest all are true. Only here you have got, see, you have to check true implying false. Is this true implying false? No, no. So it is this, correct. Then finally you have the last column, you have negation P or Q. So negation P is here. This is negation P and Q. You have disjunction of these two. You have disjunction of these two. So what is it? Negation P or Q. You know the law of disjunction. If both are false, then false, otherwise true. So negation P or Q, both false, no. Yes, so this is false. Both false, no, no. So it means rest all are true. Rest all are true. So students, now you can check column number 6, 5, 6, and 7. Let me highlight this. Let me highlight the column 5, 6, and 7. What you notice? You notice that these three columns give you identical entries. You can check all the entries here are identical. It means these statement patterns are logically equivalent. Remember students, you may have more than two statement patterns logically equivalent. You can have three, you can have four, five, six. They all can be logically equivalent if they have the same truth value for they have the identical truth value for the given set of truth values of their component statements. So here what will be the answer? The same answer that you wrote here from column number 5, 6, and 7. As you have here 5, 6, and 7, you will write the answer from column number 5, 6, and 7. We notice that all the entries are identical. Therefore, the given statement patterns are logically equivalent. That you will write here. From column number 5, 6, and 7, we notice that all the entries are identical. Hence, the given statement patterns are logically equivalent. So that statement you can always write. So it's for you. You can once again check everything. So after completing the logical equivalence of statement patterns, you can have few practice problems. I have written some practice problems. Like, you don't have to follow the numbers, you are just concerned with the question. So whichever textbook you are following or whichever notes you are following, you can have the questions from your textbook or notes. For few practice problems I have given you, you can just practice here. You have to prove that these statement patterns are logically equivalent. Similarly, you have to prove that these two statement patterns are equivalent. You can understand this is the sign of logical equivalence. So you have to verify that following statement patterns are logically equivalent. After completing logical equivalence, we move to the next very important part in mathematical logic, and that is negation of compound statements. Negation of compound statements. So this is going to be very interesting, students. Negation of compound statements. Anyways, you all know whenever there is a negation connective, the things become so very interesting. See, if you have true, the truth value is true, and you have negation of true, then it is false. If you have negation of false, then it is true. So what does actually negation do? If someone asks you what is the job of a negation connective, so you have to say negation changes the truth value. Negation changes the truth value. If a compound statement, suppose I have a compound statement P, I have a compound statement P, and P happens to be true. The truth value of P is true. Now I'm writing negation of P. What will happen? The truth value of negation P will be false. The truth value of negation P will be false. On the other hand, if I have a statement Q whose truth value is false, if I write the negation of Q, then the truth value will be now true. So what does negation do? Negation changes the truth value of a statement. But what you noticed here, you notice that P is a simple statement. P is a simple statement. Here Q is also a simple statement or a component statement. In this section, in this section, I'm going to teach you how to write the negation of a compound statement. How to write negation of a compound statement. What I mean is, if I have to write negation of, if I have to write negation of P and Q, what will be negation of P and Q? P and Q is a compound statement. You understand that this is conjunction of two component statement. It is conjunction. We are going to learn how to write negation of conjunction. We will also learn how to write negation of P or Q, that is how to write negation of disjunction. It is a compound statement. Negation of disjunction. We will learn how to write negation of implication. P implies Q. You know, this is an implication statement. Implication. We will also learn how to write negation of P double implication Q. This is biconditional. This is a conditional statement, and this is double implication or biconditional statement. Double implication. So in this discussion, what am I going to teach you? I'm going to teach you negation of compound statements. How many different types of compound statement we have? We have conjunction, disjunction, implication, double implication. Very important concept. We are going to learn to write negation of compound statement. So one by one, I will take all these. So let us begin with negation of conjunction. So the first one is negation of a conjunction. Negation of a conjunction. So remember, if you have negation of P and Q, this is conjunction P and Q. If you have negation of P and Q, then it is always negation P or negation Q. It is negation P or negation Q. So what actually you are doing? In layman's language, you can say you are writing, you are just distributing the negation to each one of these component statement. You give negation to P, you give negation to Q, and you just change and to or. See, and is changed to or. And is changed to or. So what is negation of P and Q? It is negation P or negation Q. So we can say here, we can make the law as follows. The law will be as follows. I will write the negation of conjunction of two component statements is disjunction is disjunction is disjunction excuse me is disjunction of the negations of component statements. I repeat again. See here, what have we written as the law? The law says the negation of conjunction of two component statements is disjunction of negation of two component statements. See, negation of conjunction of two component statements, negation of conjunction of two component statements is disjunction of the negation of two component statements. So negation of conjunction is the disjunction of negations. Very simple one. You have to learn the law. What is the law? The negation of conjunction of two component statements is disjunction of negation of two component statements. Then after this we have the next one as negation of disjunction. Second I write is negation of a disjunction, negation of a disjunction. There is some technical issue in the writing tool, so I beg your pardon for this. Again and again this is happening. Negation of a disjunction. So here negation of P or Q. See, this is disjunction. And what am I doing, students? I'm writing the negation of disjunction. So be careful. What am I going to do? Just check. The negation of disjunction is negation P and negation Q. Negation P and negation Q. So what you saw in layman's language, what you can say is when you had the negation of disjunction, then what you did was you just distributed the negation to both. You wrote negation for P, you wrote negation for Q, and you changed or to and. You changed or to and. This is how you get it. Okay. So what we did, negation of P or Q, I wrote negation P, I wrote negation Q, I wrote negation P, I wrote negation Q, and what I did was this or is changed, connective or is changed into and. So if I want to write the law for the negation of disjunction, how would the law go? See, the law will be as follows. The law will be as follows. I will have the law as follows. The negation of disjunction, the negation of disjunction of two component statements is conjunction of conjunction. See, negation of disjunction is conjunction of their negations. It is conjunction of their negations. Is conjunction of the negations of component statements. These two laws, students, there is one more name given to these two laws. These two laws are also known as De Morgan's law. You can also call this law as De Morgan's law. This and this, that is, negation of conjunction is disjunction of their negations, and negations of disjunction is conjunction of their negations. These two are also known as De Morgan's law. This is also De Morgan's law. After doing negation of conjunction and disjunction, the third one we take is negation of an implication. The third one is negation of an implication. This is most interesting, negation of an implication. Let me have an implication statement as P implies Q. I want to write negation of P implies Q. I want to write negation of P implies Q. So what actually I want? I want negation of P implies Q. I want, this is P implies Q. This is P implies Q. This is an implication statement. And what I want negation of P implies Q. I want its negation. Now, before I write the negation of P implies Q, I want to prove something for you. Let me first of all prove something for you and see what is it. To prove that, P implies Q is logically equivalent to negation P or Q. To prove that P implies Q is logically equivalent to negation P or Q. This is what I want to prove. P implies Q is logically equivalent to this. Great. Fortunately, students, you will check here that we have already proved it. You will check here that when I taught you the logical equivalence, there I solved a problem for you where we proved that P implies Q is logically equivalent to negation P or Q. We have already proved it. This saves our time, fortunately. Very good. So P implies Q and negation P or Q, these two are logically equivalent. They are logically equivalent. Definitely P implies Q is also logically equivalent to this. But right now, as of now, I'm not interested in this. I'm interested only in this and this. So what I got, my dear students, I got that P implies Q is logically equivalent to negation P or Q. So let me remove to prove that. Here I will remove this part because we have already proved it. What I will write is, here I will write we know that. I will write here, instead of writing to prove that, now I write we know that. So what I know, students, I know that P implies Q and negation P or Q, they are logically equivalent. Now see, students, when these two are logically equivalent, let me take negation on both the sides. Let me take negation on both sides. So I write here, writing negation on both sides. on both sides. So see what I will get. I will get here negation of P implies Q equivalent to negation of negation P or Q. Now see students, what will happen next? This side I notice, observe this, I notice that on this side what I have, this thing here is, this thing here is nothing but conjunction of negation P and this is, sorry, this is nothing but disjunction of negation P and Q. Here what I have disjunction of negation P with Q. In between these two I have disjunction. And if you remember, just few minutes back we had written disjunction of, we had written negation of disjunction. What is the negation of disjunction? Negation of disjunction is the conjunction of their negations. It is the conjunction of their negations. So here the next step I will get is, see, the next step I will get negation of disjunction is negation of their conjunctions. So here I will get negation of negation P. I write negation for the first one. This disjunction will become conjunction and I will write negation for the second one. What did I do? Very simple. I just distributed this negation. Negation for the first one, negation for the second one, and this became conjunction. This became conjunction. I hope you all must have followed this. Next step. Now you all know students, if I have negation of a negation, negation of a negation, then it will become the original statement. It will be P. Negation of negation gives you the original statement. And here you have and negation Q. So you got P and negation Q. And what is your left hand side? The left hand side is negation of P implies Q. So my dear students, we have got the result here, what we were working for. What was the result that we were working for? We wanted to write negation of P implies Q. So remember, negation of P implies Q is P and not Q. What is negation of P implies Q? Negation of P implies Q is P and not Q. So I write the answer here. I write the answer here. It is P and not Q. P and not Q. I will also write the answer in verbal statement. So here I write, as we wrote the laws for negation of conjunction and negation of disjunction, I will write the law for negation of implication. I will write the law for negation for implication. So here is the law. Negation of if P then Q. Mind it students, what are you writing? Are you not writing negation of if P then Q? What is this? This is if P then Q. We have done it so many times. P implies Q is also read as if P then Q. So here see how does the law go. The law goes as follows. Negation of if P then Q is see what it is. It is P and not Q. What it is? It is P and not Q. Is P and not Q. Is it not so interesting? Negation of if P then Q is P and not Q. It is P and not Q. Very interesting. Now I tell you one very important thing which normally students commit mistake. You know, they forget that when you are writing negation of if P then Q, when you are writing negation of if P then Q, it never starts with if. See, remember this. When you are writing, so here I write a warning. It's a warning. What is the warning, students? The warning is when you are writing negation of if P then Q, never start with if. What it is? It is never starting with if. It is simply P and not Q. Negation of if P then Q is P and not Q. So here let me write the warning. Negation of if P then Q never begins never begins with if. It never begins with if. I give you an example for this. Suppose here I have a statement. I have a statement here. If you give if you give 100 rupees, if you give 100 rupees, then you will get a ticket. Look at this statement. What is the statement? If you give 100 rupees, then you will get a ticket. So this statement is an implication, very clear. If then it's an implication. Now what I want negation of this statement. I want to write the negation of this full statement. See, the negation of this statement will be as follows. Now I write the negation. Be careful. What is the warning? Never start with if. So remember students, if I consider this to be P, if this is P and this is Q, if this thing I take it as P and this statement I take it as Q. So what do I have here? I have here P implies Q. So I have here P implies Q. And what I want negation of P implies Q. I know negation of P implies Q is P and not Q. P and not Q. So be careful. What will be the negation of this verbal statement? Let us write the negation of the above verbal statement. See, P and not Q. What is P? You give 100 rupees. So P as it is. You give 100 rupees and negation Q. What is Q? You will get a ticket and you will not get a ticket. You will not get a ticket. This is negation. How interesting. This is the negation of above statement. So I hope you all have followed the negation of an implication. What is negation of an implication? Negation of P implies Q is P and not Q. Negation of P implies Q is P and not Q. Let's have few more practice. See here. Negation of P implies R is P and not R. Negation of R implies Q is R and not Q. Negation of R implies P is R and not P. This is one thing. And always remember that when you are writing, you can check here. The warning was never, negation of if P then Q never begins with if. It doesn't have if. You can check. How you can check? Here you have, here you have implication, but when you wrote the negation, do you have any implication here? No. And that is why there is no if. When you are writing the negation, there is no if, it is just the conjunction. I hope you all have followed. You can watch this again and again to get the expertise. Thank you. After negation of implication, the next part is negation, that is fourth one is negation of double implication. Negation of double implication or negation of biconditional statements. So what is a double implication statement? It is P double implication Q. This is a biconditional statement, P double implication Q. And what I want to write the negation of this double implication statement. I want to write negation of this. So before I write negation of double implication statement, I write a logical equivalence here, and I want you all to prove that logical equivalence on your own, because we have done enough examples on logical equivalence. So I want you all to prove these logical equivalence. So let me first teach you this logical equivalence, and after that we will come to negation of double implication. Remember students, when we have P double implication Q, it is nothing but P implies Q, and in return it is getting implied by Q. You all know P implies Q is an implication statement. So when you have P double implication Q, what is happening? When you have P double implication Q, then P is implying Q and Q also implies P. Q implies P. What is happening? P implies Q and Q implies P. That is, in between you have conjunction. So remember that double implication, P double implication Q is logically equivalent to P implies Q and Q implies P. So this is the logical equivalence which I'm writing here, and I want you all to prove this. So here, see, the logical equivalence is P double implication Q. P double implication Q is logically equivalent to P implies Q and Q implies P. This is the logical equivalence. So this is the true statement. It's the left hand side here and the right hand side here, these two statement patterns, the statement pattern on the left and the statement pattern on the right, they are logically equivalent. So if they are logically equivalent, let me write the negation of left hand side and the negation of right hand side. If these two are logically equivalent, their negations will also be logically equivalent. So what I will have, I write here, writing negations, writing negation on both sides. So I get negation of P double implication Q equivalent to negation of P implies Q and Q implies P. Okay, now I want you all to follow this. Students, see this right hand side statement pattern. What do you notice? Don't you see, that you got here conjunction of two statements? What you have here inside the bracket, you have conjunction of two statements, and you know that negation of conjunction is disjunction of their negations. So when I will write the negation of this bracket, what actually I will do, I will write negation of this, negation of this, and I will write or for the and. Okay, so see, the next step I will get is, I will get negation P implies Q or negation Q implies P. Now next step students, you all know that this is negation of implication. Negation of implication. Is this not P implies Q, and here we have negation? This is Q implies P, and here we have negation. We have already done recently, just few minutes back, I taught you negation of if P then Q. What is negation of if P then Q? It is P and not Q. P and not Q. Or negation of if Q then P, it is Q and not P. And what is left hand side? Left hand side is negation of P double implication Q. So my dear students, we got the final result here. You can see what's the final result. The final result is negation of double implication is this. Negation of P double implication Q is P and not Q, or Q and not P. Remembering this is very simple if you remember this logical equivalence. This logical equivalence. I know P double implication Q is P implies Q and Q implies P. So when I will write the negation, it's going to be the negation of this, and this will turn into OR. So negation of this is P and not Q, Q and not P, and this will be OR. So here you have the negation of double implication. I hope you all must have followed this. You can watch this once again. Several times you can watch and get the expertise.